Now we turn our attention to part B of question 1. We have already found that for critical damping, R has to be 50 ohms. We have found what is the transfer function between Vi and V0 for that value 50 ohms, for L 1 microhenry, and for C 100 picofarads, which is this one. Now the input is given. They told us here, part B. If the input V of t is 4 volts times the unit step U of t, compute what is V0 as a function of time. So the input is 4 volts times the unit step. Its Laplace transform is 4 over s. If we multiply that input in the Laplace domain 4 over s times the transfer function of the circuit for R equals 50 ohms that we found in part A, this one, 4 millions s divided by s plus 100 millions, all of that squared. When we multiply that, what we get is the output of voltage. This voltage here as a function of s, and that is the Laplace transform of the output of voltage. 4 times 4 millions is 16 millions. S cancels out s in the denominator, and we're left only with the denominator term s plus 100 millions squared. Now let's find the inverse Laplace transform of this one. Square s plus. Whenever we shift a Laplace transform by a, as in here, we multiply its anti-transform f of t by e to the negative at. So the function of time is shifted by this amount, so its anti-transform is multiplied by e to the negative 100 millions t. But 1 over s squared is the transform of the ramp. So this is a ramp multiplied by an exponential 16 millions t times e to the negative 100 millions t multiplied by the unit step of volt. And that is the output of this circuit when the input is 4 u of t. And that was part B.